Good morning, sir.
Last class we completed till ray diagram of compound microscope.
Yes.
What is magnifying power defined as? Ratio of angle subtended by the image at the center of lens to the angle subtended by object when placed at distance of distinct vision and seen directly. Magnifying power of simple microscope we got as d
E
upon,
by U.
and if image is at ddb, also
Plus
called
DD.
as near point, also called as normal position, then we got magnifying power as 1 plus d
E by F.
d by f, and for infinity we got d upon
D by
f,
F.
only d upon f. Now we have to prove in compound microscope magnifying power is equals to product of linear magnification, and magnifying power of eyepiece. Compound microscope consists of how many lenses?
Two.
Two.
Two lenses. One is objective
Eyepiece.
and eyepiece.
IP.
Objective is close to the object. The object is placed at a point slightly away from focus f0, and we get magnified real image a1 b1. Let u naught and p naught be the distances of object and image respectively. The eyepiece is adjusted in such a way that object A1 B1 lies between F and P of eyepiece. Let UE be the distance of object from eyepiece, and VE be the distance of image, beta be the angle subtended at center of lens. This much we have done in last class, correct?
Yes, sir.
Right. The compound microscope, the compound microscope consists of two lenses, objective and eyepiece. The objective is smaller than eyepiece. Objective is smaller than eyepiece. It is situated close to the object. Is situated close to the object. the object AB is placed at distance u0 slightly beyond focus f0. The real inverted slightly magnified real inverted slightly magnified image is obtained at distance v0. This image A1 B1 behaves as object for eyepiece. The eyepiece is adjusted in such a way that the eyepiece is adjusted in such a way that the object A1 B1 lies within focus and optical center. Just complete this one. Please complete it.
Yes, sir.
No, sir, no, sir. Just
So,
Yes.
so could you send the that answers of 52
Yes,
MCQs?
I was about to ask just now how many of you have completed. I think only you have completed full. Others have done the homework.
Yes, sir.
yes, sir.
Okay, okay. Please keep on doing the homework and don't fool anybody. You have to do the homework regularly to score better marks. That's why I've given only 25. Just after the class in 10 minutes, I'm sending the solution of that.
Yes.
Can I clear this now?
Yes, sir.
Withdraw.
The eyepiece is adjusted in such a way that object A1 B1 lies within the focus and optical center. Shall I clear now, Soham?
Yes, sir.
Lies within focus and optical center of eyepiece at distance UE. The virtual magnified image is formed at distance VE. that beta P angle subtended by final image at center of eyepiece. It's completed now.
Done, sir.
From the figure, tan beta, which is approximately beta, equals to opposite side A1 B1 upon UE. A1 B1 is downward, therefore minus. UE is on the left, also minus. This will get cancelled. Equals to A2 B2 upon BE. Again, this is downward, left will get negative, negative, but cancel. Now, magnifying power m dot p is beta upon alpha. Alpha is a b upon minus b. I am taking first term a1 b1 upon u. So this is a1 b1 upon ue into d upon ab minus. So minus a1 b1 upon ab into d upon u. What is a1 b1? Is it height of image of
Yes,
object?
sir.
Object.
So a1 b1 upon ab is nothing but height of image to the height of object, which is called as linear magnification of object.
Yes, sir.
Okay, please copy this much, then after clearing I will do the formality. Complete till end.
Yes, sir.
Everybody is done,
Yes, sir.
but a1 b1 upon ab equals to m naught equals to linear magnification of objective d upon ue equals to magnifying power of eyepiece. Therefore, magnifying power of compound microscope is minus m naught into ne. Negative sign indicates that final image is inverted with respect to object. Copy. Yes, done.
Yes, sir.
Now that those two cases, image at DDV and at infinity wala to get for compound microscope. Case 1. Final image is at DDV. Therefore, magnifying power is minus MO into ME can be written as also V naught upon U naught in place of A1, B1 upon AB. We can also write V upon U, which is distance of image to the distance of object. The height of image to the height of object, we write V naught upon U naught into. So what is linear magnification for real image? Minus V upon U, which is height of image upon height of object. So this I can write upwards plus. Okay, this much you followed? Hello?
Yes, sir.
Linear magnification for objective is real image. Real image के लिए V upon U in minus होता है. So we can write this as V upon U minus minus will become plus into ME. ME is 1 plus D upon FE. Clear?
Yes, sir.
Case 2. Final image is at infinity, which is also called far point, which is also called as relaxed height. Magnifying power will be V naught upon U naught into D upon FE. Write these two cases. Yes, completed.
Yes, sir.
Okay. Do you have diagram in front of you? A compound microscope.
Sir.
Can you tell me what is distance between objective and eyepiece? Distance between
V0 plus UV.
beautiful, correct. Distance between objective and eyepiece also called length of tube or tube length, comma L equals to V naught plus UE, correct. So sometimes they will give you distance between tube, that means V naught plus UE. If final image is at infinity, then can I say UE is focus? Then only final image comes to infinity. If the object is at focus, see this is suppose eyepiece, this is the object at focus, then final image will come at infinity. This you are knowing, the ray becomes parallel, so final
Yes, sir.
infinity. So when final image is at infinity, UE is FE. So can I say then L will become V naught plus FE? Hello?
Yes, sir.
Yeah, write this much again to as a note. Sometimes in numerical they will give length of the tube. That means you should recollect it is nothing but V naught plus UE. If final image is at infinity, then UE is same as FE. Yeah, can I clear?
Yes, sir.
Okay. One more note. Then we'll start with magnifying power of telescope. If final image is at infinity, then magnifying power is V naught upon U naught into D upon Fe. This can be written in terms of length of tube as L upon Fo, this quantity, into D upon Fe. Just copy this. How we got this? By using 1 upon V minus 1 upon U is 1 upon F naught. So this is V naught U naught. When you adjust as V naught upon U naught, then we will get final answer as L upon F. At the end, I will explain. I will not waste time right now.
And
Okay. Next is magnifying power of telescope. Magnifying power of telescope. See, in telescope, we don't have object at distance of distinct vision. They are always far object. So definition of magnifying power of telescope, also called as astronomical telescope, will change a bit. It is defined as the ratio of angle subtended by final image at center of eyepiece to the angle subtended by object at center of objective. Therefore, magnifying power is beta upon alpha. But it is not object placed at DDV. Object may be anywhere, angle subtended by object at center of objective. Write this magnifying power of astronomical telescope. Complete fast.
hence,
Okay. derive expression for magnifying power of astronomical telescope. Magnifying power of astronomical telescope. First we have to draw ray diagram, then from that get beta and alpha. So draw one horizontal axis, which is actually principal axis. Your objective size is larger than eyepiece because it has to gather light from the object coming from far distance, therefore it is made larger. So this is objective. Object is at very far distance, therefore rays will be almost parallel to each other and making very small angle with the principal axis. And passing through optical center, it will emerge out without any deviation or lateral displacement. Another ray will pass through focus, not focal, pass through focal plane, not focus because it is not exactly parallel to the principal axis. Here the rays from object AB at very far distance. This makes angle alpha, so here also angle will be alpha. Now after passing through the lens, they will meet at a point which is not focus but in focal plane. They will meet at a point. I am calling this image as A1. P1 meets at focal plane. Therefore, this distance is FO, that is focus of objective. Now, eyepiece is adjusted in such a way that A1, B1 lies within focus and optical center of eyepiece. So, eyepiece, we adjust this object in such a way that it lies between focus and optical center, that is distance of object becomes Fe. Now whatever distance you are taking this, exactly same you take on other side for focus. Now ray parallel to principal axis will pass through focus and passing through optical center will remain undeviated. So these two rays will be parallel to each other. That means the rays when converged backward, they will be parallel only, they will not meet at a point. That means final image is at infinity. Angle subtended is beta. Please draw a diagram. Yes, done.
Sir, that's done.
Okay.
Answer.
Now you all can see alpha is nothing but opposite side A1 B1 upon adjacent side FO. Can you see from diagram? This is alpha, which will be this in this triangle opposite side A1 B1 upon adjacent side FO.
Yes, sir.
And beta will be this opposite side and this adjacent side FE. So from the
Yes, sir.
figure I can get alpha beta, hence I can get magnifying power. So first line we'll write this. It consists of two lens, that is objective and eyepiece. The objective is larger than eyepiece. The object is situated at very far distance. The image AB A1 B1 of object AB is obtained in focal plane of objective at distance f0. Let alpha be the angle subtended by object at objective. Copy first paragraph. I think completed.
Yes, sir.
Everybody is done.
Yes, sir.
Okay. The image A1B1 behaves as object for eyepiece. The eyepiece is adjusted in such a way that it lies in such a way that the object A1B1 lies at focus Fe of eyepiece. Hence, final image is at infinity. Let theta be the angle subtended by final image at center of eyepiece. Right.
Answer.
From the figure, alpha equals to opposite side A1 B1 upon FO. FO is on the right, so positive, A1 B1 downward, negative. Beta equals to opposite side A1 B1 downward, so minus. Fe on the left minus, this will get cancelled. So this is A1 B1 upon Fe. Magnifying power comma m equals to beta upon alpha, which will be A1 B1 upon Fe minus A1 B1 upon Fo. So magnifying power is A1 B1 upon Fe into Fo upon A1 B1 minus I am taking here. So this A1 B1 cancel, minus Fo upon Fe. Right. Minus indicates final image is inverted. That's it. So in magnitude, magnifying power is ratio of FO to FP. Copy till this.
Done.
Everybody is completed till FO upon FP.
Yes.
Now can you tell me what is length of this telescope?
FO plus FE.
Correct. So length of telescope is magnitude of FO plus magnitude of FE. Note, when final image is at D means distance of distinct vision, then magnifying power minus FO upon FE into 1 plus FE upon D. This part we don't have in our book, but we can derive this. So length of telescope will be FO plus. Now final image is not at infinity. So object this image, this distance of A1, B1 is some distance UE. So 1 upon B minus 1 upon U is 1 upon FE. B is D and this is UE equals to 1 upon FE. And length of telescope will be FO plus UE. When you simplify this, it will come FO plus UE will come, UE will come, FED, actually it is V times F upon FE plus T. In mirror, I will explain how that distance V is FE into U upon U plus F. Copy. When you simplify this, you will get UE as FED upon FE plus D.
Done, sir.
Okay. Now just open the PDF of ray optics which I have sent you earlier, not last class, earlier. and come to question number 28. On page number 4, question number 28. Just scroll backward, you will get that PDF. Heading is given ray optics. Come to question number 28. Are you getting? Should I tell you the date when I send that?
Sir, got, sir.
21st February I have sent you. Come to page number 20, page number 4, question number 28. One. The magnifying power of simple microscope is given 6. Focal length of its lens, if least focal length we want. If least distance of distinct vision is 25 centimeter. Now since image is a DDV, what is magnifying power formula? 1 plus D upon
150 by
focal length, okay, D by F. So 6 equals to 1 plus 25 by F. 5 equals to 25 by F. So F is 25 upon 5. F equal to 5 centimeter. That is 0.05 meter, option A. Any doubt in the sum?
No, sir.
No, sir.
So directly optical instrument is actually easier part. Formulas are many that you have to remember. Is completed. Can I go to the next sum?
Yes, sir.
Last sum for today. Sum number 29. An astronomical telescope has angular magnification of magnitude 5. The separation between objective and eyepiece, that is f4 plus fp, is 36, and final image is at infinity. So focal length f4 and fe of the eyepiece we want. We know m equals to f4 upon fe in magnitude. So 5 equals to f4 upon fe. Therefore, f4 is 5 times fe. Since f4 plus fe is 36 centimeter, so 5 times fe plus fe is 36. 6 fe is 36. So fe equals to 6 centimeter. And fo is 5 times fe, 5 into 6, 30 centimeter. So objective 30, eyepiece 6. Which option? Just check. D. Yes, I think completed fully.
Yes.
Yes, sir.
So that's all for today. Please keep on revising. As I've given you the sheet, within 10 minutes, I will send you on the common group solution of that.